Author and international speaker, Jay Seegert holds degrees in both physics and engineering technology. As founder of the Starting Point Project, Jay passionately seeks to help people establish a biblical worldview based on the authority of Scripture. For more than 30 years, he has been graciously tackling tough questions regarding the Christian faith, especially in the often intimidating world of science, bringing it down to a level that everyone can understand. We trust you will enjoy this presentation as Jay delivers a fascinating talk entitled Evolution, Probable or Problematic?
Well, welcome back to our presentation of Evolution, Probable or Problematic. This is part 2. Trust that you were able to catch part 1, critical information that's background to what we're moving into here, discussing the creation-evolution controversy, which is a big stumbling block for a lot of people, wondering what are we to think about this. You know, scientists tell us it's an absolute fact and nobody doubts it, but what are we to do with the whole creation account as found in Genesis? Is it just allegory, just poetry, not meant to be taken seriously? Maybe there are some errors or contradictions there. Well, that's a big problem for us as Christians if we can't trust the Genesis creation account, because if we can't trust God for what He tells us about the beginning, how can we trust Him for anything else? So we're going to be moving into part 2 here, and one of the first things we need to do is review part 1. So, in review of part 1, one of the biggest things we covered there was defining our terms, specifically the idea of evolution. Evolution is not just change. We see change all the time. And what happens is people say, well, evolution's an absolute fact because we see change all the time. So if you say you don't believe in evolution, they're going to look at you like you're crazy that you don't believe change when everyone knows things change. Evolution would involve change, but it's not just any kind of change. It's a very specific type of change, which we're going to find out we don't see in nature. So that's very critical. We're certainly not talking about different varieties of dogs that we have on the planet, or different cats that are around, or even different beaks on finches that Darwin got very excited about. These, again, are facts of science. Nobody denies these things. But again, these changes have nothing to do with evolution as they're teaching it in the public school systems and state universities. They tell us that there was a single-celled organism almost 4 billion years ago that slowly turned itself into every other life form on this planet on its own over millions and millions and millions of years. This, I personally believe, is a story that's told about the past because no one was around to see that actually happening. Now, we also call this molecules to man evolution. Dead chemicals came together to form a living cell, which then turned itself into every life form, including human beings. And I would recommend that you use that terminology when you're talking with someone. If you say you don't believe in evolution, you might want to say you don't believe in molecules to man evolution. Dead chemicals became alive and then produced every other life form on this planet. Otherwise, they're going to think you reject change, which isn't going to go well for your conversation. Now, we did cover the built-in variation in part 1. Part 2, we are going to be specifically focusing on random mutation. Random mutations are accidental copying errors in the DNA. When the DNA copies itself, some mistakes happen, and that's what we're going to be looking at more specifically in part 2 here. Now, here's interesting information about random mutations. This is from University of California, Berkeley. They said mutations are essential to evolution. They are the raw material of genetic variation. Without mutation, evolution could not occur. So they're telling us that mutations are critical. You've got to have mutations, otherwise you can't have evolution. Very, very important for evolution. Well, they also say mutations can be beneficial, neutral, or harmful to the organism. Well, theoretically they can be, and that's a whole other talk to talk about beneficial mutations and some of those details, but we're going to be looking specifically at these mutations in general. Are they going to improve things and get better and better, or are they causing insurmountable problems for us? Let's talk just for a moment here about error correction. Again, these mistakes are happening in the DNA. Well, the DNA actually has the ability to correct these mistakes, which is interesting. In fact, we see that on a good day, about 1 million bases in the DNA in a human cell are damaged. These bases, basically, we're going to be talking about the rungs in the DNA here. 1 million of them are damaged every day in our cells. We've got up to about 100 trillion cells in our body. So a lot of damage is occurring, and it needs to be corrected or we couldn't function or even be alive. Well, what's interesting is these very elaborate error correction systems are actually coded on the DNA. You need DNA to make those error correction systems, but you can't have DNA surviving without them. So it's the classic chicken and the egg scenario here. Which came first, the chicken or the egg? Well, which came first? DNA with all its complexities, or the error correction system to correct these mistakes? You can't have one without the other, but you can't evolve them over millions of years by accident. They need to both appear at the same time. Huge problem for the whole idea of evolution. We're going to talk next how evolution allegedly works. So we are now going to be transformed into a state university science classroom, and I'm going to be a PhD molecular biology professor telling you how evolution works. And this is how it goes. We've got a single-celled organism up here that's going to reproduce itself. So it needs to copy its DNA. So it does that and produces children. And you can see the children look pretty much like the parents because it's a copy of the same DNA. Then the children reproduce, and we now have grandchildren that look pretty much like the parents and the grandparents because it's a copy of the same DNA. And then the grandchildren reproduce, and oh, we got a problem going on here. We got some serious mutations. Some of them apparently are bad, others apparently look like they might be good. Then natural selection comes along like a superhero and wipes out the bad mutations and tends to keep the good ones. And then reproduction continues. And the new good ones reproduce themselves, so we have more of the new ones. And then the original ones continue to reproduce, we have more of those as well. Can you imagine the great variety of life we would have on this planet through this process happening over millions and millions of years? Now here's the point. I believe that the non-Christian students sitting in this classroom, hearing that presentation, think to themselves, makes perfect sense to me. You can't argue with that. I mean, this is my PhD molecular professor, telling me about all of this. It's a fact. This is what scientists have proven. You could see it for yourself. But I guarantee you, the Christian students sitting in that classroom see that and they say, it makes perfect sense to me too. I guess the Genesis creation account isn't correct, wasn't meant to be taken seriously. Maybe there are some errors or contradictions. And many of them end up walking away from their faith due to that and other factors going on. Well, we are now going to take a closer look at these mutations. Some of you are familiar with Paul Harvey, a famous radio announcer. He was famous for telling us the rest of the story. And that's what we're going to look at next, is the rest of the story regarding these mutations. Can they do what evolutionists tell us they do? I'm going to make 3 major points about mutations. First of all, that they are random, purposeless, and undirected. Secondly, that they occur in the DNA. And thirdly, that they're almost entirely detrimental or bad. We're going to start out looking at the first point, that they are random, purposeless, and undirected. Here's an interesting quote from Nova Online. This is an evolutionary source. This is what they had to say. It's sometimes convenient when trying to make sense of evolution to think of changes within a species of having a purpose, as though Mother Nature has some intended goal that she sets out to achieve. The bacteria want to survive, someone might reason when thinking about the declining effects of antibiotics, and so they evolve into resistant strains. Of course, there is no purpose in evolution, just random mutations within DNA, most of which are detrimental to the survivability of the organism. Those are the 3 points that I just made on the previous slide. They're random, there's no purpose to them, they're occurring in the DNA, and they're basically bad. Very interesting. Well, here's another interesting quote from Discovery News talking about dinosaurs. Presumably, the sauropods evolved large body size as a strategy to deter predators. Well, what are they saying here? Well, apparently it goes something like this. At some point in history, dinosaurs weren't as large as they eventually came to be. So they're sitting around the campfire one night, and they're talking, saying, hey, you guys, we need to come up with a strategy to deter our predators. Otherwise, we're going to go extinct much sooner than we're supposed to. Do you have any ideas? They say, no, our brains are too small. And one of them says, I got an idea. What if we get some machine guns? We could shoot our predators. First dinosaur says, no, we can't do that. They haven't been invented yet. It's like, okay, good point. Second dinosaur says, I got an idea. What if we hopped onto our motorcycles? We could ride off into the sunset. First dinosaur says, no, they haven't been invented yet either. Third dinosaur says, I got an idea. What if, just what if we evolve really large body sizes, we could scare them away? First dinosaur says, now that's a good idea. Are we all in agreement? Okay, break. And they go off and they get big. I don't know a scientist on the planet who believes that. They don't believe that a creature needs something and so it evolves it. But we have a problem with the popular literature. Often they'll talk about the fish swimming around in the oceans millions of years ago, and then food started to become scarce. And so they needed to evolve lungs to crawl up onto land to find new sources of food. And the students write it down. Makes sense to me. I mean, they got to do something. They're running out of food. They're going to die if they don't do that. But here's the question. How do fish even know what lungs are? I know they swim around in schools, but even if someone taught them what lungs are, what are they going to do about it? All they have is genetic information to make gills and other fish parts. And even if they could try, how are they going to survive over millions of years as their gills stop working underwater, but they can't breathe air yet up on land? They're not going to be able to survive. The scenario doesn't make any sense, but often the students, they don't really even have time to think it through. And all they know is they have to pass this test, to pass this class, to get a degree, to get a job, to live in the real world. So what do they care? Just put it down and move on. It doesn't matter one way or the other. And that's typically what can happen in the university setting. Well, that was the first point about mutations. The second point is that these mutations are occurring in the DNA. So we're going to take a very quick look at DNA here. DNA is like a very, 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 very complex blueprint with lots and lots and lots and lots of information on it. So let's take a look briefly at the storage capacity of DNA. Let's say you had just a teaspoon amount of DNA and wanted to back up that information onto CDs. And we back up our computers once in a while in case they crash. So we're going to back up that information on CDs. Now, a single CD can hold about 100,000 pages of text on it. So how many CDs would we need? Well, you would need 100 CDs, but don't write that down because that's not true. You would need 1,000 CDs, but don't write that down either because that's not true. You would actually need 1 million CDs, and that's only partially true. You would need 1 million CDs given to you every minute for 9.5 years. Then you'd have enough CDs. That's 5 trillion. Might give you an appreciation for our national debt, but that's amazing. But you know what we're taught? Oh, all that's just an accident. Just particles smashing together. Nature created that elaborate information storage system. Well, here's another look at DNA. DNA is like a very huge set of complex information that we would find in encyclopedias. In fact, the letters inside the encyclopedias are represented what we call nucleotides. Those are the rungs on the ladder. So each rung is like a single letter out of that whole set of encyclopedias. Then when you group a bunch of rungs together, that's how we form words. You group letters together, you get words. You group these rungs together, or nucleotides, and that's how you get words. When you put thousands or tens of thousands of these rungs or nucleotides together, that's how you create a chapter out of the set of encyclopedias, which is what we call a gene. You're familiar with the term, the gene in our DNA? Genes are chapters in the set of encyclopedias. Then when you put thousands of these genes together, that's how you get a chromosome, which is a single volume out of the set of encyclopedias. And then when you take a look at the entire set of encyclopedias, that's what we call the genome. For people, we call it the human genome. That's a little bit of biology 101. Many of you probably already knew much of that, but it's kind of interesting. Now we're moving on to the third point, and this is where things start to heat up, that these mutations are almost entirely detrimental or bad. And again, this is where I think it gets really interesting and where you can really make a decision. Does evolution seem probable or problematic? Now here's how the story of evolution goes, and I say story not to be derogatory or condescending. It truly is a story of what they believe happened in the past, because again, they weren't there to see it happen. They can't reproduce it in a laboratory, and they can't really test it directly. So it's their story of what they think happened millions and millions of years ago. As part of this analogy, let's say that the amount of information in a single cell bacteria is about the amount of information we find in a biochemistry textbook, which is true. The amount of information is equivalent there. But remember, we need to change that single cell all the way into a human being. So we can't just copy it, we need to make changes. So continuing our analogy here, I'm going to use this book here, Biological Information, New Perspectives. This was birthed out of that bioinformatics symposium from Cornell University. This is the information that came from the 27 lectures that were given during that time. We're going to look at just one page, some sample text here, highlight some of the text, put the text off to the left, but we can't just copy this information. If we just copy this over and over and over, millions of years from now, we'll just have a lot more of these textbooks. We've got to change it. Well, what are these changes? The changes are the mutations that we've been talking about. So let's look at some example mutations. These will be point mutations. First of all, we have a duplication mutation. We take the ending L in level and we duplicate it. There's an extra L there. It no longer spells level. But I know what you're thinking. If you were reading that, you'd say, oh, it's just a typo, and it's level, and you'd move on. That's not how our genes work. Our DNA would see that and say, I don't know what this is. I've never seen it before. It's meaningless. And it would move on. It destroyed that piece of information. Another example of a mutation is a deletion. We take the M out of the word model. It doesn't spell model anymore. Third example is a substitution mutation. We take the P out of probability and put a Z in there instead. It doesn't spell probability. These are examples of point mutations. Now here's where it gets kind of interesting. You could ask a kindergartner, what is your favorite book? And they tell you some book. And then you ask them, if we took your book and just randomly opened it, closed our eyes and stuck our finger in there, and whatever letter we touch, we just delete it. And then we open it up again and stick our finger in somewhere else and we duplicate that letter, put an extra one in there. And then we open it up again and we touch another letter and we take that letter out and just put another random letter in there. And we just keep doing that. What would happen to your book? Will it get better and better and better? A kindergartner will tell you, no, it's going to get worse and worse. In fact, I won't even be able to read it after a while. A kindergartner understands this. You have to be highly educated to not get this. And again, I don't want to be condescending here, but that's often what happens. These scientists are plenty smart. They don't need more information. They need a different starting point to use to interpret this information, because facts don't speak for themselves. So these scientists are plenty smart, but many of them aren't even aware of this, and those who are hoping that someday they'll find an answer. They have faith that someday they'll figure it out, but right now it is a huge obstacle for the idea of evolution. But the challenge for evolution gets much worse than that. Everything we've already covered here, it's going to get much worse as we think this through, specifically looking at the DNA and talking about how the information is structured on the DNA. We're going to be looking how information is written. We're familiar with how books have information. Now we're going to look at how information is structured on the DNA. So as an example, let's say you were looking at your DNA and it spelled out, was it a rat I saw? Kind of a strange phrase here, but we know in English that we read from left to right. You may have already noticed You can actually read this backwards. Was it a rat I saw? It's called a palindrome. Read it forwards and backwards. It's kind of fun, again, not very meaningful, but it can go both ways. This is what we've discovered about our DNA, that much of it can not only be read forwards, but it can also be read backwards. But guess what? The challenge for evolution gets worse than that. Take a look at this phrase here, desserts. We flip this around and it spells stressed, which is what I get when I don't have desserts. Now, let's introduce one of our random mutations here. We'll just randomly delete the T. It doesn't spell desserts, but it also doesn't spell stressed. One random mutation messed up two messages because they go forwards and backwards. But we don't see just little words that flip back and forth in our DNA. We actually see up to entire chapters of complex instructions that can be read forwards and backwards. And let me give you an analogy so you understand how challenging this actually is. Let's say you have a job working in a smartphone factory, and it's your training to write the instruction manual to give to the manufacturing plant for them to make the phones. Your boss comes to you one day and says, I got a project for you. I need you to write the chapter in the manual that explains how the phone is going to download apps from the web. You say, yeah, I can do that. He says, okay, thanks. Then he's walking away. He goes, sorry, I got one minor detail I left out here. When you write that chapter, you have to write it in such a way that if we read it backwards, it's going to explain how the phone's going to play music files. And you're looking at him like, I mean, you're kidding. I mean, just being funny, right? And he says, no, I'm sorry. We only have so much room in the manual. It's got to be read forwards and backwards. That is humanly impossible. It cannot be done. You can't even program a computer to do that. I did computer programming for 18 years. It can't be done. But that's what we're seeing in our DNA. We read it one direction. It's a set of complex instructions that make certain proteins that carry out a certain function in your body. We read it backwards, completely different set of instructions that create completely different proteins that carry out a completely different function in your body. Two major points with this. Number one, particles smashing together in nature will never create an elaborate data information system like that. And number two, when you make random changes to that, you're not going to make it better and better. It's going to get worse and worse. But the challenge for evolution does get even worse than that. We have overlapping information in our DNA. Take a look at this strange phrase here, I like chocolate later that evening. Why is it strange? Because it's two phrases. I like chocolate, which is true, and then later that evening. The two phrases overlap. And the four letters in the middle, L-A-T-E, they share those letters. This is what we've discovered about our DNA, that we've got overlapping messages. Well, let's introduce a random mutation here. We'll just randomly take out that E and put a Z in there. It doesn't spell I like chocolate, and it doesn't spell later that evening. This is what we're seeing in their DNA, overlapping messages. But we don't see just a few letters that overlap. We see up to entire chapters of complex instructions that actually overlap each other. It is absolutely amazing. But the challenge for evolution gets worse than that. We have spliced information in our DNA. Take a look at that same phrase again, I like chocolate later that evening. Let's underline a few portions and then bring them down below. It spells, I like her hat. This is a spliced message. Let's introduce one of our random mutations here. We'll just randomly delete the H. It doesn't spell I like chocolate anymore, but it also doesn't spell I like her hat. One random change mess up two messages because they're spliced, and that's what we see in our DNA. But we don't just see a few letters in our DNA that can be spliced. We see up to long sentences and short paragraphs that can be spliced. What does that mean? This is what it's like. Think about reading that biology textbook. Read the whole thing. You just learned a lot of information. Now you go back and you just take out kind of random long sentences and short paragraphs from different places in the book, put them together. now you have another set of instructions. That, again, is humanly impossible. You can't do that. You can't even program a computer to do that, but yet that's what we're seeing in our DNA. But guess what? The challenge for evolution gets worse than that. We actually have embedded messages in our DNA. Take a look at this sentence here. Can you show Mike Owen checks from Oliver's latest facts and set it on the desk? Strange phrase. Let's circle every 8th letter here and bring them down below. It spells out chocolate. There's a theme going on here. It's my talk. I can do that. But this is what we're seeing in our DNA. There's actually embedded messages. Now, let's just introduce another one of our awesome random mutations here. We'll delete the H. It messes up the main sentence, but it also messes up the embedded message, because what it does is it shifts all the letters after that mutation over one spot. So now if we circle every 8th letter, it would be these letters here, which are completely meaningless. So one random mutation here messed up 2 messages, the main message and the embedded message. But guess what? The challenge for evolution gets even worse than that. We have encrypted messages in our DNA. I actually had 2 interviews with the CIA to work in their cryptographic analysis division. Very interesting and strange story for some other time. But let's talk about data encryption here. Got a strange, somewhat meaningless phrase going across the screen here. But what if you found out there was actually an encryption key here, meaning everywhere you saw an H, it's actually an A. Everywhere there's a B, it's actually a C. Everywhere there's a Y, it's actually a T. So these 2 Y's up there are actually T's. If we make all the substitutions, it spells out this is an encrypted message. This is actually what we have going on in our DNA, encrypted messaging. Now let's take just a second to think through what would be required to create an encrypted message system. Keeping in mind that there's no God, there's no creator, no designer, just particles smashing together in nature. And that's basically the crux of what they're teaching in the public school system and state university. Whether the teachers or professors believe in God or not, they are not saying God was involved here, he did this, he did that. No, they're saying we can basically explain everything through science. So what would be required to create an encrypted message system by particles banging together in nature? Well, we'll take a look at this. Here are the steps. Number 1, you have to develop a language system using symbols. So when we've got these 3 sticks here, if we put them together this way, that's going to be an A. And when we have these 3 shapes that way, we're going to put them together like this, and that's going to be a B. You have to create an entire alphabet by particles smashing together in nature. Step 2, you have to create and define words. So when you put these 4 letters together that way, that's going to represent that object. You have to create an entire dictionary of words and definitions by particles smashing together in nature. And then you have to be able to write meaningful sentences and paragraphs, which actually requires rules of grammar. How do particles smashing together in nature create rules of grammar? Fourthly, you have to establish the encryption system with that key. Fifthly, you have to create the system that does the coding and the decoding. And then sixthly, you have to develop the ability to read and carry out the instructions, or the whole thing is useless. How do particles smashing together in nature do this? I don't know a scientist on the planet who can even begin to explain how this is possible. Yet, by faith, they believe it must have happened. Again, a lot of the scientists aren't even aware that this is going on. Those who are have faith that just somehow it could happen. To me, it makes a lot more sense that this is evidence for design. But the challenge for evolution actually gets worse than that. One last time here. We actually have 3D information in our DNA. I'm actually skipping a few details here. You can thank me for that later. But 3D information. This is a little harder to depict with PowerPoint here. I'll do my best. When DNA makes proteins that carry out all the functions in our body, they're not these little straight ladders. They get folded up into very complex 3-dimensional formats. And if they don't get folded just right, they're disassembled and their components are reused. So I'm going to take 7 words on the screen here, and I'm going to, quote, fold these as best I can. I'm going to stack them on top of each other. And when we stack them this way, you're going to notice there's an additional piece of information going up and down, the word success. Now, if you don't fold these just right, or again, if we make some random mutations, change letters, duplicate things, delete things, we're going to lose that piece of information. Random mutations are not going to make it better. They're going to make it worse and worse. So if we don't stack them right, they get shifted around, and we just destroyed our additional piece of information. So what we see in conclusion here is that certain things might look great from a certain distance or a certain angle, like that bright red BMW. We envisioned opening the hood to see the beautiful engine. While we opened the hood on evolution and we found out the engine truly is missing. There's nothing to drive evolution. Here's an interesting quote from a geneticist. He said, "Genetics has no proofs for evolution. It has trouble explaining it. The closer one looks at the evidence for evolution, the less one finds of substance. In fact, the theory keeps on postulating evidence and failing to find it, moves on to other postulates, fossil missing links, natural selection of improved forms, positive mutations, etc. This is not science." Now, we've got one more quote for you that you probably are familiar with. That's Genesis 1:1. "In the beginning, God created the heavens and the earth." The more we take a look at science, the more sense it makes to me that there is a God, there is a creator, and that he created things just the way he told us in the book of Genesis, which gives us a lot more confidence that we can trust Scripture from cover to cover. So I hope that you are encouraged by this particular talk. And again, this is not about trying to disprove evolution or prove creation. This is ultimately about the authority of God's Word, that it is trustworthy from cover to cover, and that you can certainly trust its gospel message about having our faith in Jesus Christ for our salvation, not about working hard and being good enough, or about not believing in evolution. It's about placing our trust in Jesus Christ and the authority of his Word. So we appreciate you spending this time joining us for this particular presentation. Hope to see you in future talks. God bless.
We hope you enjoyed this presentation and trust it was an encouragement to you. For more information about our ministry and resources, visit us online at thestartingpointproject.com.